Every spill is unique in terms of its circumstances and consequences and requires a specific response. When an oil or chemical spill is threatening to pollute the coastline, the temptation is great to rush into cleanup operations as quickly as possible. When a spill or pollution risk occurs, the first thing that must be done is to accurately assess the situation. Many factors must be accurately assessed, such as the source of pollution, the type of pollutant, the weather conditions, the type and sensitivity of sites threatened or already affected, as well as the ecological or socio-economic importance of the area. These elements will help to establish a response strategy and to deploy appropriate human resources and equipment. Once the situation has been assessed, the authorities, polluter, site owners, advisors and field responders, who will all have diverging interests and stances, must meet in order to define response strategies which comply with each party's technical, environmental or economic concerns. The cleanup sites and resources to be deployed are defined by the worksite command centres, with support from technical advisors present on site. First and foremost, it is essential to organise response by adapting the size of the work area according to the operations to be conducted and by setting up a base camp. This facility, close to the cleanup area, is set up to ensure operators' comfort and is where they will get changed and eat and drink. Meetings are also held here to inform responders of the health and safety rules defined by the competent health experts.
Today is going to be much the same as yesterday. We're going to be carrying out the same operations. 5 people on manual recovery, 3 people sand screening, and 2 on waste management. Don't forget all the safety rules. Wear personal protective equipment at all times. Don't forget that as soon as work is finished, you must go through the decontamination area. The better you look after your personal equipment, the better your working conditions will be. Any questions? No? Okay, let's go. My job is to apply the techniques in accordance with the type of site and the pollution present, to ensure that these techniques are respected as work progresses, to provide a daily progress report, where necessary to adapt techniques throughout the day as the situation may evolve, to provide all necessary elements to the operators and decision makers in order to continue operations in the best possible conditions.
My role is to guarantee the physical integrity of all field personnel. Safety should be the aim and priority of each individual throughout operations and at all times. I must therefore ensure that safety instructions are followed and make sure that any victims of accidents on site are properly dealt with.
If equipment breaks down, operations automatically come to a stop, so it's important to fully understand all the technical means used on site.
A traffic system must be set up. To do so, the routes and access paths to the different areas of the worksite must be marked out and protected so as to avoid transferring the pollution to uncontaminated areas. These routes should, wherever possible, be determined using existing access points and tracks. Waste management is a fundamental component of response. Waste should be able to be stored in the immediate vicinity of the cleanup sites on a signposted and protected planned site at which the different waste sorting categories will be identified. If the storage or evacuation chain is ruptured, work on site will systematically have to stop. containers compatible with the type of pollutant as well as the quantities extracted will be placed on this site. To prevent leaching of polluted waste by rainwater, containers will be covered with lids or tarpaulins. Bunds and trenches will be built around the storage site to contain any runoff. Waste will generally be evacuated to an intermediate storage site or a predefined suitable disposal channel by road. On certain very ecologically sensitive or difficult access sites, the technical and financial feasibility of evacuation by sea or by air should be investigated. Cleanup systematically begins with operations to remove accumulations of pollutant and heavily contaminated materials as quickly as possible. Once the threat of new arrivals has been eliminated, final cleanup operations are generally carried out to restore sites to their previous uses. To do so, a wide range of techniques is available to responders, which will be adapted according to the substrate and the type of pollution. Operations involving simple or manual techniques can be implemented by non-specialised personnel, supervised by a trained team leader. However, complex techniques involving specific equipment and knowledge should be contracted to specialised companies.
On hard substrates, initial cleanup generally involves the manual removal of solid waste on the shoreline, followed by the collection of accumulations of oil. According to the pollutant and the site characteristics, oil can be collected either by manual scraping or scrubbing operations, or by pumping or suction of the pollutant on the substrate or accumulated between the boulders of riprap. Different water flow techniques can be used to wash down the area and force oil out of cracks where it may be trapped, pushing it towards a prepared recovery area, most often in the form of a trench dug at the foot of the cleanup zone, or a containment area set up on the water surface. Following initial cleanup, more advanced operations may be carried out, which on this type of substrate generally involve removing the oily film from the substrate by pressure washing using hot water. On sand and pebble beaches, initial cleanup generally involves collecting solid waste. On pebble beaches, this is done manually, but on sandy beaches, it can be mechanized using tractors fitted with hooks, rakes, or even sand screeners, usually used to collect litter on popular tourist beaches. According to the conditions, accumulations of pollutant are then removed by manual techniques using oleophilic rollers, or even suction or pumping means. Hoses can also be used to flush the substrate and push accumulated and buried pollutant towards a recovery zone.
Ou infiltrés enfouis dans le sable vers une zone de récupération qu'on aura préalablement aménagée. Le nettoyage fin de la plage de sable peut ensuite passer par...
Final beach cleanup can involve different screening techniques, using sand screeners and mini sand screeners. Final cleanup of pebbles and stones involves either pressure washing with hot water directly onto the substrate with a limited efficiency, or using sacks that can be turned over to wash the entire surface of the pebble. However, the most efficient technique is the use of a concrete mixer, which acts as a pebble washing machine. Finally, it is important to remember that natural cleanup is an option to be considered. Pebbles and sand can be washed by wave action. This natural capacity can be promoted by moving oiled pebbles down to the surf zone, a technique known as surf washing.
In port areas like we have here, which are generally sheltered and well protected, the first reflex we should have should be to contain the pollutant as close to the source as possible. However, the fire and explosion risk must have been measured and considered sufficiently low or negligible to allow containment. In this case, we use booms, which are already positioned on site, as close to the containment area as possible. These booms can be deployed by specialists, such as coasting pilots or specialized companies.
Comme des lamaneurs ou des sociétés spécialisées. Ça peut aussi se faire par des opérateurs.
They can also be deployed by non-specialized operators as long as they are trained. In this case, regular exercises are carried out for operators to practice deployment. Once the pollutant has been contained, the containment line is made oil-tight by creating countercurrents or adding sorbents to seal off the containment area.
Type absorbant pour bien fermer la zone de confinement.
Once this has been done, recovery can be carried out. Initial recovery should be carried out by specialised companies or operators trained and supervised by specialists or technical advisors. Vacuum trucks, mechanical weir skimmers or oleophilic skimmers can be used for recovery. To finish off recovery, or else to recover very small spills, we use sorbents. Peat is often used as it acts as a natural sorbent, but it can be difficult to recover unless the area is extremely well sealed off, and suitable equipment to recover these relatively fine particles is required. There are also loose or bulk sorbents, such as sorbent spaghetti, which are slightly easier than peat to recover, but still require containment to be set up beforehand. Finally, there are sorbent pads or booms, which are easier to recover and dispose of. Every day, worksite record sheets are sent along with expert assessment reports to the command centre. Decision makers therefore have all the technical and environmental elements needed to reassess the situation, organise response for the following days, adapt strategies deployed, and plan the resource mobilisation. This goes on until operations are called off and worksites closed down. These documents, which must be carefully archived, will be used to establish a financial review of operations conducted and may subsequently be used for compensation purposes.
A well-run worksite is a worksite on which the techniques applied are entirely appropriate to the pollution on the site and the site specificities, its morphology, and the types of sediment. If we have already worked on contingency planning on this site before it was contaminated, we will already have a lot of information to help us in decision-making and in implementing operations.
Shortcuts must not be taken when setting up a clean-up site. On-site organisation, as well as the deployment of equipment, tools and techniques, depends on operator training. Through training, responders will be informed of the risks associated with the different types of operations they are liable to conduct.
Exercises enable decision makers, operators and supervisors to test equipment, progress in its implementation, and above all, ensure its maintenance.
Every worksite is unique and requires decision makers and operators to be reactive, adaptive, competent and knowledgeable.